What is up everyone, Nick here, and in today's video we're going to continue working on my latest project, the Iron Man Mark 6 armor from the MCU. The goal for this project is to build a highly accurate and a highly durable Iron Man cosplay with a ton of features that will be as durable as it is cool. In the last video we covered my plans for this suit along with how I scaled and 3D printed the motorized helmet, along with some of the electronics I wanted to incorporate into this project. And in this video we'll be checking out how I intend to build the gloves for this suit, specifically how I was able to motorize them and include lasers just like in the movie, along with motion-activated repulsor blasts. And we'll also be checking out how I scaled and 3D printed the lower torso, as well as how I got all the pieces to attach together and fit around my body. Now when it comes to the repulsor gloves, I have gone through a very long process of improving them over time across all the Iron Man suits I've built. For example, my very first iteration for the Mark 20 suit just used a simple 3D printed raft material to glue the handguard directly to the glove, and some elastics to create the pivot point for the handguard. Now this worked at first, but it was very unreliable and would break all the time. Like seriously, the handguard would just pop off and fly into space. So I ended up redesigning the gloves slightly. Now they have a 3D printed hinge for the handguard right here with some elastics, and the handguard straight up bolts into the glove with some screws. That way the handguard is staying put. And on top of that, I left some room inside the handguard for all of the electronics. Specifically, there's a microcontroller inside to control the lights for the repulsor, and on top of that, there's an ESP8266 which sends wireless messages to my helmet to control the faceplate. Now, as cool as the electronics sound, it doesn't work all that well in practice. The reality is there's still a bunch of wires leaving the glove and going into the forearm for power and to control the lasers I had in the forearm. And this is the exact same method I employed when I built my Iron Man Mark 46 suit. And this system was only improved when I finally built the Mark 42 glove almost exactly a year ago. In the Mark 42 glove, I had the majority of the electronics soldered to a single PCB, except for the Adafruit LiPo charger, which had to be attached separately. But with my new glove for the Mark 6, I have every single electronic component bolted onto a single PCB, including the Adafruit LiPo charger, and it isn't that much bigger. And if you want, you can order your very own repulsor PCB from this channel sponsor, PCBWay. PCBWay is the industry leader when it comes to PCB manufacturing and 3D printing solutions. From custom circuit boards to innovative 3D printed prototypes, PCBWay offers unparalleled quality, fast turnaround times, and competitive pricing. And make sure to check out PCBWay's big Christmas sale kicking off from November 28th to December 31st. You can save up to 50%, get free upgrades on premium PCB colors like purple, matte black, and pink, and even snag 10% off select 3D printing materials, including UTR 8100 transparent and Somos Lido. So make sure you check out the link in the description to get $5 off your very first order. And I will also be including a project link to where you can get this PCB along with the code. Now, if you want a full-on tutorial on how to build a glove like this, I highly recommend you go check out the Mark 42 glove video, since that covers it in detail. And I also talk about the glove in a separate video where I cover how to do the wireless Iron Man helmet with voice recognition. So those two videos should provide all the information that you need to build it. But for now, let's jump into 3D printing the glove and the lower body. Oh man, that is very up close. Let me back you up a little bit. So at this point, I think we're like a week and a half into the process. I have the files now and I have taken a look at them. There's honestly not a whole lot I can critique about them. They're very accurate. I like the way they all come together and assemble together, except for a few little things. So since the suit is a 3D model that anybody can buy, a lot of the mechanisms for the motorization and whatnot are meant to be glued in place, which isn't a bad thing. Like, that's actually a really good method of, scaling and making it accessible to anybody who buys the files. Personally, I really like mechanical bonds for attaching my stuff. So there is going to be a process where I add a bunch of holes and a bunch of little mounts so everything can be screwed into the plastic using brass threaded inserts, which is what I'm actually having done right now with the gloves. So I actually ended up commissioning Neon Robotnik to modify the glove files to add all the threaded inserts and whatnot. For the rest of the suit, I'm probably going to be doing that. The very first thing I did do was scale them to my actual hand size. So I ended up printing one at 100%. It's a little big, like you can see it moves around on my hand. It's super easy to put on and off though, which, is cool. I also 3D printed one. I think this is 90% scale. This is a little too small. Like you can see, I'm having a hard time pushing my hand in, and it's a little uncomfortable for me to try and close my hand. So probably not gonna go with this. And the last one, I think I 3D printed at 95% scale, and this one fits me just fine. Anyways, I just wanted to give you guys a breakdown of what I've been up to lately. Currently, my 3 main focuses for this suit right now, before I really get into the nitty-gritty and start 3D printing like these gigantic pieces, is for one, the gloves, because I think they're really neat, and there were a few features I wanted to add to them, like pivots. That way I can actually do repulsor blasts and have the handguard like tilt and whatnot. And of course the helmet, which we got 3D printed in ASA. It's at 105% scale, fits my head really nice. And the other part I want to focus on before I start 3D printing everything is the lower body. So similar to the head, I am only 5'7", which means the scaling of the suit is super important for how it actually looks on my body. A taller, skinnier person can get away with a lot because they can just make the pieces bigger. For me, however, I need to make the pieces as small as possible, that way the proportions all look good. And combine that with the fact that I've actually gained a little bit of weight in the last few years, the lower ab section is really important to get right. So the first step of the process is actually weight loss, so I started going to the gym daily. I'm on a diet. If everything goes well, and I hope it does, I should be able to lose weight by February, like about 30 pounds, which should help with the fitment of the lower body quite a bit. I'm a little skeptical that the current files at 100% scale will fit me. Definitely not on the Z-axis. The Z-axis needs to be shrunk down a little bit because it is a bit long, but I did compare it side by side with the other 3D model of the lower body I 3D printed for the Mark 46. Not the Mark 46 I built, but the Mark 46 I was building and had prototypes of for the Extremist design. Basically, Hot Toys released an exclusive figure that used the Mark 46 as a base, but it included some comic accurate parts that made it look like the Extremist suit. Anyways, all that to say that I actually have the lower body of that suit here with me. This is the modified version that I was building. So let me just move the camera real quick so you guys can actually see this. Oh, hi Python, how you doing? Okay, hopefully you guys should be able to see this, but basically, this is the lower body of the Mark 46 suit. You have the abs, you have the oblique pieces, you have the little hip skirt, and then you have the spine. Now, if you've been keeping up with my other projects like my Tron Ares cosplay I just made, this is where the whole idea for TPU mounts came from. So let me disassemble it for you guys. I used quick release safety pins for the ab pieces. These are very similar to the ones I used in the original Mark 46, except much longer. The reason why I went with longer safety pins is because, in my mind at least, I'm not an engineer, it distributes the stress of wearing the suit across a much longer surface instead of just like a 1-inch point. And in my original Mark 46 suit, I actually didn't 3D model the piece that this slides into the 3D model. I 3D printed it separately and fused it in place. So after wearing it, eventually the 3D print just gave out. I couldn't wear it, it just blew out. I had to tape it back together. Anyways, long story short, that's the reason why I'm going with these longer ones, because I think it might be better, but time will tell. Let me remove the other one here on the other side. There we go. So you can see the crotch panel is attached with some TPU with screws, which screw directly into the plastic with some threaded inserts. And then the rest of the lower body also uses TPU all across the spine like this and on the side for the hip. That way it all flexes just like this. So that allows me to wrap the suit around my lower body. Let me reattach this ab plate right here. With one ab plate attached, let me tilt this down for you guys. So with the ab plate attached on one side, I can just wrap this around my body just like that. And then we can insert our quick release pin, close it, and then push it into the holes just like that. And that's how the whole lower body fits. So the idea is I want to reuse this exact same method of slicing the pieces and attaching them back together for the Mark 6. But before I do any of that, I need to make sure that the files will actually fit me. So I'm gonna modify the parts slightly so that they're easier to print. And then I'll probably just fuse them back together, maybe use some elastics to glue it in place. I'm just gonna be 3D printing it out of some really cheap PLA. That way I can get the fit right. Then I'll be able to modify the lower body and then 3D print the final pieces and actually try it on, maybe reprint it in a slightly different scale if I need to. But yeah, this actually fits me pretty well. And where I'm at right now is that since the Mark 46 one fits me so well, like it's not uncomfortable, there's plenty of room, especially in the back. Sorry, Python. Technically, the Mark 6 one at 100% scale along the sides here should still fit me, but they are differently shaped, so time will tell. And by time will tell, I mean probably in the next few days, because I'm gonna start 3D printing that right now. Anywho, let's get this corset off and let's get to it. So I actually lied. First, I'm gonna show you guys how I add my TPU inserts to my 3D prints. So right now we're inside of 3D Builder And these blue things right here are the TPU mounts, and this white thing is the TPU mount itself. You can see there's little holes inside of the TPU mounts, and those are for the threaded inserts. So first I'm just gonna group them all together. That way I can make it one object, and then we can move it to our piece that we're going to be adding all the TPU mounts to. You want to make sure that whatever part you're modifying, and in this case we're doing the lower body, is located in a specific set of coordinates. In this instance we have it set to 0x and 0y. That way we can make duplicates later and always add them to the exact same location. But first we're going to grab our TPU mounts and bring it to the actual lower body. Now we're going to be placing it along one of the seams of the 3D print. So in this case, we're attaching it to one of the sides of the obliques and the back. So you can see the seam is right down the middle. That's perfect. That's where we want to place our TPU insert to attach both halves together. Now we're going to rotate it and make sure that the TPU mount is clipping into the parts, but not too far, because we don't want the inside of the TPU mounts to be clipping, because the holes are where the threaded inserts are going to go. So we want to make sure that the TPU mount is clipping just enough that it makes contact with the 3D print, but not enough that it clips through the holes. This is probably the most tedious part of it, because there's a lot of finagling and adjusting millimeter by millimeter and degree by degree, but I find it easiest when we actually paint the part we're modifying. So in this case, I'm going to be painting the entirety of the lower body red. That way I can see the inside of our TPU mounts in white and see if it's actually clipping. So I'm just gonna click on color, click select red, and paint all of these parts red. Now it's a lot easier to tell whether or not the insides of our TPU inserts are clipping through the part. So when I push it in, you can see red appears. That means it's clipping. So we need to pull it back slightly. You can see the two bottom ones are clipping, but not the top ones. So we're gonna change the angle of the pitch slowly but surely, and now none of them are clipping. Now we need to duplicate this on the opposite side of the abs. So we're going to select all of them. We're going to hit Object, Duplicate, and now we're going to reselect the original ones and take note of the x-axis. So right now it's at -152.4. We're going to mirror our copy and place it at 152.4. And now we have an exact copy on the opposite side of the abs. Now we need to repeat this process for all of our other TPU mounts. And once we've gone ahead and placed all of our TPU mounts, we need to select all of the parts of our lower body and duplicate them along the x-axis. So we can grab this bit, move it around, and go to Object and click on Duplicate. And once it's duplicated, we can just move it to the side. And now we're going to select all the parts of our original lower body, group them all together once they're all selected, just like that. And now we're going to edit mode, and we're going to hit subtract. Now this is going to take a while, but it's going to subtract all the parts of our TPU inserts that are clipping through the part. And now you can see that our TPU inserts have been cut to shape to the inside of our lower body, but there are some little bits that are sticking out that we are going to need to delete. So we're going to ungroup them, select these little bits that are garbage, and we're going to delete them. We only want to keep the side that has the screws. So again, I'm going to select these, ungroup them, and then delete these extra bits that we no longer need. And once you do that for all the parts, we can then reselect the lower body that we made a duplicate of. And once we have all of these pieces selected, we can hit the X coordinate and bring it back to 0. And now all of our TPU inserts are perfectly lined up and placed inside of our lower body. The only part we have left to do is to fuse them to the correct part. So I'm going to grab these two, grab the oblique, and fuse that together. Now I'm going to grab these two, grab the back, and fuse them together. Basically, you're going to take every single TPU insert that is making contact with a specific piece and group it with that piece. So I'm going to grab these bottom ones at the abs. I'm going to grab these two that are attaching the cod to the lower part of the abs and fuse them together. And I'm just going to repeat this process for the entirety of these TPU inserts. And now you can see that they're all fused together. All the ones for the back are attached. and all the ones for the butt plate are also attached all together to the butt plate to attach it to all the other parts. And if you guys want to use the TPU mounts too in your own projects, I'll include the files in the description. Now, I 3D printed a few parts for the lower body at 100% scale, except for the Z-axis, which was at like 90% scale, I think. And it doesn't fit at all. I only got around to 3D printing the back and also the front cod segment. And just by putting it around my own body, I was able to tell that this just wasn't gonna work. So I went back and rescaled it, but instead of changing the scale of the parts themselves, like in percentages, like I usually do, I followed Frankly Build's tutorial on how to scale cosplay armor, and specifically I used Danny's method of stretching pieces in Blender. And it works exactly like it sounds. You're basically taking your 3D printed part and you're pulling on it to stretch it to make it bigger. I'll leave a link up here so you guys can go check out that video. And the reason why I decided to use this method was because the torso itself is pretty well scaled, specifically the upper half. If I were to make the upper half of the body any bigger, it would be way too big for me and there would be a lot of room inside the armor. But the problem is, if I were to scale this lower body any bigger, then I would inherently have to scale the back and the chest up so it would fit around the lower body, instead of having them collide or even potentially having the lower body overlap with the upper body, which I don't want at all. So by stretching the part to the scale that I need, I'm preserving the dimension of the upper half while increasing the size of the lower half to fit me, which I'm gonna show you guys right now. Here we go. So here we have the abs and the lower cod piece, and the back piece, which is the lower back, the butt, and the oblique pieces along with the little butt flap right here. And this is all attached using the TPU inserts we just installed. I'll most likely be adding even more into the final version. This was just to keep everything together. Also, I don't want to be wasting threaded inserts on prototype parts, so I'll just be adding more TPU mounts later to the final piece. And we also have these bits right here for our safety pins. Actually, let me grab those. So here we have our quick release pins. They're the exact same ones as the Mark 46 torso I showed you guys a bit ago. Now, all I have to do is drop that on the floor and attach these together just like that. And then we can grab one of our quick release pins. Then all we need to do is just slot that in there like that. And now we have one side connected. And then I can just put one safety pin here just to keep it in place. Wrap this around my lower body, just like that. Then all we need to do is just line this up. There we go. That took a little bit more work than I thought. So we have the lower body in place. Everything is looking pretty good. The only issue is this front half here. So there's only one TPU mount attaching the cod piece to the abs, and I'm guessing with the way that it fits on my body, it's tilting it forward, which means that it's completely unaligned along this seam. But besides that, everything else is perfectly aligned, which is great. I'm just gonna need to find a solution for this here. What I might end up doing to fix this is just slice it along this seam here and have this piece be attached right here instead. That way, there's only going to be a little bit of a gap instead of a really big one here. And one other thing I'm considering doing before I start 3D printing the final version is slicing the back and the butt piece into multiple pieces, and then just using TPU mounts to attach everything back together. And the reason why is because I want to make sure that each part of the Iron Man suit can be as compact as possible. That way, when I'm traveling, it's super easy to just disassemble everything and pack it into my luggage. Ideally, I want to be able to fit it into one single nano case instead of fitting it into two, because traveling with two big pieces of luggage can be pretty expensive. Also, I just want to make it easier to 3D print because right now I do need to trim the edges of the butt plate down, or else it just doesn't fit on my K2 Plus. So yeah, outside of this panel kind of being annoying, I'm pretty happy with the proportions of this lower body. And since I stretched the parts to actually fit me in Blender, this seam along the lower body should fit perfectly inside of the upper body. Now, I did need to modify the cod piece significantly because the original one mounts like this to the upper half of the cod plate, and as you can see, it's pretty straight, narrow, and small, and there's just not a lot of room for the human anatomy. So I needed to make some changes. Let's see if I can detach it as easily as I put it on. There we go. And I gave myself some room so I'm not too uncomfortable while wearing the Iron Man suit, especially down there. I need it to be as comfortable as possible. But with those changes, I'm pretty satisfied with the scaling of the lower body, and I think we're basically ready to move on to some other pieces of the suit. But for today, we're only going to be taking a look at the gloves, so let's go check that out. Yeah, baby. Okay, so let's talk about the gloves. So initially, when I started making Iron Man suits, I would have all the electronics for the lights and whatnot be in the suit and have wires running down my arms. Now this is bad for two reasons. Number one, the wires will like move over time and they'll bend and they'll flex, and the more they do, the more they'll be prone to breaking eventually. And well, I don't want my stuff to break while I'm wearing it. And on top of that, it's just an absolute pain to actually put on because you have to explain to your handler how everything fits together, how to plug the wires in, and honestly, it's a tight fit, so it's usually a real big pain. And I think I've been experimenting with wireless gloves for the past year now, having the battery be inside the glove with all the electronics. And then I started prototyping a brand new glove for the Prime Armor, which I never made. And this one's pretty neat. Let me get up close for you guys. So the handguard wasn't attached to the glove initially, and it's only one piece. It was just floating over the glove. So I decided to design a mounting point that would not only attach it to the glove, but also work as a pivot. So as I lift my hand, this moves out of the way. And the way this works is that there's two hinges on either side. So you can probably see right there, there's a screw hole and another screw hole there. Because initially it was screwed right through with a washer, I just removed those so I can take the handguard off. And there's a spring right here which pulls the handguard back into place. And I can just pop this off just like that, and we can see the electronics inside. So we have our ESP32S3 Mini, which is for the wireless stuff and to control the lights. Then we have the kill switch here, and we have another USB-C port right here, which is linked up to the Adafruit LiPo charger right here, so you can charge it from this port instead of this one since it's not accessible. And on top of that, it's USB-C instead of micro USB. Who uses micro USB in the year 2025? I have no idea. And then at the bottom right here, we have an accelerometer. Now the accelerometer detects the motion of the glove, and that's how I'm able to trigger the repulsor blast and the light turning on and off. So if I throw this on real quick, I can give you guys a live demo. So let me flick the switch on and put the glove on. So when it's facing down like this, it's off. When it faces up, it turns on. And just like you guys saw in the first part, it sends a wireless message to the soundboard, and that triggers the sound effects. And same idea when I move my hand back, it does a little flash animation. You can't really tell. I might have to improve the colors and add some yellows and whatnot so you can really see it. And then when I tilt my hand back down, it turns off. So I'm going to be incorporating this exact PCB into the new suit, but I'm going to be using it slightly differently. So let me show you guys. Yeah, let me unplug this. There we go. So it's a bit hard to tell, but there are 4 connectors here. There's 2 3-pin connectors and 2 2-pin connectors. Now right now I'm only using 2 out of the 4. So one of them is for the RGB light, which needs 3 pins. It needs power, it needs a negative, and it needs the digital input. And then the other pin is for the button, which is located on the side right here, which is also probably the best position for a button inside of a glove when it comes to Iron Man stuff. Because initially, I've had buttons on the top of my knuckles where I would have to lift my fingers up to press it, and I had a lot of issues with that because either one, I would clasp my hand around something, like let's say a doorknob, and I would accidentally hit a button, or it would be so close to my knuckle that it would kind of dig into my skin and be really uncomfortable. So the solution to that was to put the button on the side of the index here. So all I have to do to actually trigger it is bring my thumb to my index like this and squeeze it together. That's a very deliberate motion, so I'm not gonna accidentally trigger it, and it's not applying any pressure onto the side of my finger, so it's not uncomfortable. Anywho, what I was going to say is that since I have the 2 extra connectors, we're gonna put those to work. So initially, the other 2-pin connector was supposed to work for a second button in case I wanted to have 2 buttons in my glove, and the other 3-pin connector was for a second RGB light. But instead of using it for a second RGB light, we're going to be using it for a servo for the back of the handguard, and we're going to be using the other regular 2-pin connector to control a laser diode. Because if you guys remember Iron Man 2 at all, which you better, you should be rewatching that every other weekend. What is wrong with you? At the end of the movie, during the big forest fight with the hammer drones, Tony says get down, and he starts firing off lasers from his handguards. Those. We're gonna be making those. So let me move the camera back so I can actually show you the models of the new glove. So Walsh actually incorporated the laser gauntlet feature into the 3D files. So it's this one piece here with a servo mount on the back, which you glue to the inside of the handguard like this, with the servo glued here, and this handguard at the back tilts on the servo. Now this is an absolutely fantastic idea, and it's a huge improvement to the Mark 7 files, which was a collaboration between Walsh and Vec3D. Those files came out way before the Mark 6 did, and they had the whole entire back of the gauntlet be part of the forearm, so you couldn't really turn the hand without one piece of the handguard staying behind and the other moving. Meanwhile, with this, everything stays together and can be mounted to the gloves. But he didn't design a pivot point, meaning the handguard can't tilt like this. Also, everything is supposed to be glued together because you can scale this. However, I don't want to rely on glue. I have in the past, and it hasn't ended well at all. For example, my Mark 20 suit had the handguards glued to the back of the hands before, and one time I gave a high five to a little kid at a convention, and the kid gave me a super strong high five, and what happened? The handguard just flew into space. It just completely detached from my glove and just yeeted itself across the room. My point is, I want everything to use threaded inserts and to be screwed together. So I commissioned my buddy Neon Robotnik to modify the files so that everything mounts with threaded inserts and screws, and I also asked him to design a pivot point for the glove. Let me show you guys something. Where is it? There it is. This here. Let me bring you guys in real close again. This is a torsion spring, so it's a loop of metal, just like this. It looks very much like a spring, with 2 legs that stick out on either end. And what's really cool about these is that you can have them pivot at the center here, and they will return to their original shape, which is very handy for making pivots, which is exactly what we have going on here. So this is the mounting plate for the servo arm that attaches to the front end of the glove. And at the center of it, you can see we have a spring right there, which is held together with a rod with a screw going through it. And it attaches both ends of our handguard together. So this is for the front half and this is for the rear half. And there's 2 stoppers on this hinge, one to keep it from overextending this way and another to keep it from overextending in the opposite direction, because I wanted the spring to be under tension even when it's closed, that way it's not sloppy at this end, which means it needed a stopper to keep it from going this way. And honestly, the rest of the glove is pretty self-explanatory, so I'm going to assemble it real quick and show you guys what it looks like. So this is the rear half of the handguard. We're just going to grab our, which is going to have the laser diode inside of, and we're just gonna place it right here and screw it down. So I'm just gonna toss in some M2.5 screws, and we're just going to screw it together like this. And then we have our servo assembly, which has a screw here for the actual arm, some screw holes here to attach to the handguard here, and it also has some threaded inserts on either side here, so that we can screw it down like this. So I'm just going to screw this onto the rear handguard assembly. There we go. So that's all one piece with the servo arm that moves just like that. Then we can feed our screws into here on this side, grab this end, smoosh that there, and screw it down, and do the same thing on the other side. Voila. And lastly, we just need to screw both halves together like this. Boom. And here we have a functional handguard with a pivot and with the laser. I'm pretty satisfied with how this turned out. It's perfectly aligned, it's springy, and since we have the stoppers to keep the handguard from going back this way, it means that this stays aligned and it doesn't apply any pressure on the servo. And realistically, when we'll be wearing the gloves with the rest of the suit, this part of the handguard will be making contact with the forearm, which means it shouldn't mess around with the servo mechanism too much. So you can probably see the holes that are right here on our handguard. This is for the circuit board to attach to. And these 2 points right here with the threaded inserts are meant to attach to the actual glove. Now, I kind of screwed up when it came to this. This was my suggestion to Neon when it came to actually assembling the glove together. I was just going to use an Allen key to fit some screws through these holes into the glove so that I could screw it to the handguard from the inside, but there's just no room whatsoever. We're going to have brackets on the gloves with threaded inserts, which align with brackets on the other end that slot together so I could screw it from the sides. So I'm gonna reprint the front half of the handguard and the glove real quick, and once those are done, we'll get back to assembling this and hopefully have the final version of our prototype done and functional. And just like that, we have our fully assembled prototype of the glove. And now we're gonna go through the process of testing everything and making sure it actually works. So I've got the soundboard module plugged into the speaker over there. I have the helmet plugged into some power along with the voice recognition and all that. And in case you don't know it already, if you haven't watched part 1 for some reason, the helmet actually responds to voice commands like this. Hey Jarvis.
At your service, sir.
Open helmet. Close helmet. Voila. Now the glove is going to work similarly. It's going to send wireless commands directly to the helmet to activate it. So let me just flip the switch, slip my hand in, and press the button. There you have it. So that'll be able to wirelessly control the helmet while I'm wearing the suit. And now that we know that this works, let's try out the repulsor blast. So if I lift my hand up, we get the sound effect. If I bring my hand back, we get the repulsor blast. And if I bring my hand down, it turns off. Now, the last thing we need to test is the laser. So if I double click it, the handguard in the back should be able to lift. Just like that. And we have our laser beam, which you can barely see on camera right now. And it closes, and it opens, and it closes as many times as I need. Now I did modify the code slightly so that when I activate the laser, it wirelessly sends a command to the other glove that we're eventually going to build so that they simultaneously turn on and turn off the laser. That way I'll be able to do the super cool pose with both lasers going crazy. So I'm going to dim the light slightly, and I'm going to use a teeny tiny little vape tank with a tiny pump and a tiny battery, and I'm just gonna manually blow some fog into the room. So let me just...
2,000 years later.
I got one hand on the fog. I got the other. I mean, you can see it, it's just barely. There we go. You can start to see the laser beam a little bit. I hope you guys are seeing that on camera. It is pretty cool. Yeah, laser beam. All right, that means I'm probably gonna have to use a much bigger smoke machine if I want that to work properly, but it's there, it works. All right, let me just hit the lights again. There we go. And that's gonna be it for today's video, guys. I really hope you enjoyed it. And again, if you have any questions about this project, please leave them in the comments down below and I will try to answer them in future updates. Huge thank you again to PCBWay for sponsoring the channel and for sponsoring this video, and I will see you all in the next one.